Today, we will be presenting our economic perspective on whether Malaysia should allocate more resources to nuclear energy. I am Zijin, and my groupmates are In Huang, Kulan, and Yusof. Our stance is that we are against the Malaysian government for allocating more resources towards making nuclear energy a major power source for the country in the foreseeable future. Our opposition derives from three main concerns, namely the radioactive waste, high upfront costs, and the catastrophic impact of the nuclear accidents, followed by the economy theory of externalities, which leads to inefficiency irregardless of positive or negative externalities. Other than energy that is produced from the nuclear power plant, radioactive waste such as uranium mill tailing, spent reactor fuel, and others are the byproduct of nuclear energy production. This radioactive waste poses environmental and health hazards to us, as the halftime of such waste can take up to a millennium. Hence, countries with a nuclear power plant spend a great amount of money and effort to safely package and dispose such radioactive waste. Having it encasted in cast iron and copper cylinders wrapped in bentonite clay. Such a process requires extreme care and advanced technology to handle, as the consequences of improper care may lead to accidents. Up to this date, experts suggest geological repositories as the best solution to dispose of such radioactive waste. Despite Finland and Sweden successfully receiving government approval to build repository sites that could dispose of high-level radioactive waste, countries such as the US and China still face massive public opposition due to the uncertainties and public distrust towards the long-term safety of such sites, resulting in the construction of such sites to be on hold. Since Malaysia is a smaller country in comparison to both the US and China, it is likely that the country would dispose of such waste to other countries' geological repository sites, thus leading to increased costs for properly dispose of such waste responsibly.
When comparing the cost of nuclear and renewable energy, we'll analyze the setup cost, production cost, energy output, and the cost of safety measures. First, the setup cost. Nuclear power plants are extremely expensive to build, costing between $6 to $9 billion per gigawatt. On the other hand, renewable energy like solar is significantly cheaper, costing between 1 to 3 billion per gigawatts. Next, the production cost. Well, nuclear power costs $30 to $50 per megawatt hours to generate. Renewable energy is more affordable at $20 to $40 per megawatts hour. In terms of energy output, nuclear power plants are highly efficient, generate about 8,000 megawatts hour per megawatt. However, depending on the technology, renewable generate 2,500 to 4,500 megawatts hour. One of the biggest concerns with nuclear energy is the cost of safety measure. Nuclear plant require significant safety investment ranging from $50 to $100 million annually to prevent catastrophic accidents and manage radioactive waste. Renewable energy, in contrast, has minimal safety costs and pose far fewer risks. While nuclear energy is reliable, its enormous setup and safety costs, along with the risks involved, make alternative renewable energy a far more economical and safer choice for a sustainable future.
Catastrophic impacts of nuclear accidents. Next, I will discuss the potentially catastrophic consequences of nuclear accidents. The Fukushima Daiichi accident serves as a stark reminder of the far-reaching impacts such events can cause. The Japanese government estimated that the total cost of the disaster reached $223.1 billion USD. This figure includes expenses related to the decommissioning of the Fukushima reactors, the treatment and disposal of contaminated water, and financial compensation for victims. Meanwhile, the Japan Center for Economic Research put the figure at a staggering $719.3 billion USD after further taking into account the final disposal costs for radioactive waste generated by decommissioning and decontamination. And here is some graph for your references for the cost of Fukushima nuclear accident. Although Malaysia, unlike Japan, is less vulnerable to natural disasters such as typhoons and earthquakes due to its geographic location, it's important to remember that nuclear accidents have occurred even in the absence of such events. The Chernobyl disaster, for example, resulted from a lack of safety culture, while the Three Mile Island tragedy was partly attributed to incompetent operators and a weak regulatory framework. There are compelling reasons to be concerned about the safety of operating a nuclear plant in Malaysia. Firstly, Malaysia doesn't have a dedicated human resource development program for nuclear power plants, and it's unclear whether the country will have enough qualified personnel when it starts building its first nuclear power plant. Secondly, some experts argue that there is still a significant gap in the legal and regulatory framework governing the safety and security of nuclear power plants in Malaysia, despite the controls introduced by the Atomic Energy Licensing Board.
The problem of externality. Let's look at the graph showing the negative externality from nuclear power plants. The blue curve represents the marginal benefit, showing the demand for nuclear energy. The green curve is the private marginal cost, covering producers' direct costs. Where these two curves meet is the market equilibrium, labeled as Q market. Nuclear power has additional costs like waste disposal, fatal accidents, environmental harm, and health risks. These external costs are shown by the social marginal cost curve in red, which lies above the private marginal cost. There are also positive externalities, such as lower carbon emissions and job creation. But according to our findings, the negative impacts outweigh these, resulting in a net negative externality. The social optimum is where the marginal benefit intersects the social marginal cost, Q optimum. Since Q optimum is less than Q market, it shows that there will be an overproduction of nuclear energy if we were to implement it. The gray triangle represents deadweight loss, indicating welfare loss due to overproduction. The market overlooks these external costs, leading to inefficient allocation of resources. In conclusion, allocating more resources to nuclear energy results in inefficient use of resources. A developing country like Malaysia could better allocate these vital resources elsewhere. Moreover, there are safer and greener options like solar energy that should be considered. Investing in such alternatives can lead to more sustainable development without the high external costs associated with nuclear power. Here are our references, and thank you for watching.